So here's a Claisen, oh, not a Claisen condensation. Here's a alpha alkylation that you can do. What is the outcome of this? Okay, well, the ethoxide is going to deprotonate this carbon, and then we're going to do SN2 right here, and we're going to end up with this product. What happens if we treat this with acid and heat it? We're going to have decarboxylation. What happens? We lose this, because this is going to the one that becomes acid, and then it decarboxylates, and we're left with just this product right there. So how do you make 2-bromocyclohexanone from cyclohexanol? And we've got these other things that are challenging you. Try the first one. Write down all of these problems and see if you can do them, and then we're going to go through them. So how do you make 2-bromo-cyclohexanone? There should be no dash there, from cyclohexanol. Well, let's write the cyclohexanol and the 2-bromocyclohexanone. Well, I'm looking at this and I can see, we've got a hydroxyl group that could have been can be oxidized to a ketone. So we probably have this as intermediate. Can I go from here to here? Yes, I know how to do that. And can I go from here to here? Yes. What do I need? Chromic acid would work, although you could have used PCC. What about going from here to there? Just acid and bromine. Remember, you wouldn't want to use base, because if you use sodium hydroxide, you get 2 bromines here and 2 bromines here. You've got to use acid to get monobromination. How can you make this from a diester? Well, this is from a Claisen condensation, so if I cut right here and put an ethoxy back on there, that gives me the diester that I need. How many carbons am I going to have? 1, 2, 3, 4, 5, 6. So this is the reaction. 1, 2, 3, 4, 5, 6. Claisen condensation. This carbon is right here with the ethoxide taken off, and then this is this group right there. How can you make this from this ester? Well, let's look at how we could do this. It's not really immediately obvious. We have right here this, you have to think about this a little bit, and you have to say, well, this looks like a Claisen condensation if I cut this off. Well, it can't be a Claisen condensation of these two together, but if I look here, if I cut that off, I could put a ethoxy group back on this. So if I took this and used it in a mixed Claisen condensation with diethyl carbonate, I could end up getting that product. So you have to have two esters here. If I had just this, I would get a much different product from a Claisen condensation. But if I have this mixed in there with this, when I treat it with sodium ethoxide, the enolate's going to do nucleophilic attack on this. You're going to lose ethoxide, and we will get this mixed Claisen condensation product. Okay, what's going to be the product of this reaction? Well, if I have potassium hydroxide, I can have an enol form here, and then it's going to want to do 1,4 addition to this carbonyl. That's going to be the product. What if I treat this with base and allow an aldol condensation to occur? What's going to be the product there? Well, what we need to do is take a look and see which alpha carbon could actually form a ring in an aldol condensation. This has to be intermolecular. So let's look. If I use this and I form a ring here, that would be 1, 2, 3, 4. That's not going to happen. If I use this one and form a ring with this, how many carbons is it going to be? 1, 2, 3, 4, 5, 6. That can't happen. And then I can have removal of water to form this ring right here.